Okay, today we're going to be learning about percent change. So in lesson 8, you learned about solving problems involving percents. In this lesson, you'll solve percent problems that involve increases and decreases. So take a look at this problem. In May, Suzanne earned $40 from pet sitting. Her earnings increased 200%. How much does she earn in June? Okay, so first consider 100%. What's 100% of 40? Well, 100% of 40 is 40 because that's 100%. How does 200% compare to 100%? So it's twice as much, 2 times as much. How much is 200% of $40? Well, we just says twice as much or 2 times as much. So you're going to do 2 times 40 equals 80. So it's 80. So how much is 200% more than 40? So what you're going to do is, since you want more than, so you take the original 40 and then add 80 to that, and you get 120. So this is $120. It's 200% more than 40. So you figure out what's 40% of, you figure out 200% of 40, then add it back in. So how much did Suzanne earn in June? She earned $120. So explain what it means when a value increases by 100% and what it means when a value increases by 200%. So when a value increases by 100, it doubles. When it increases by 200%, it triples. Because you have to add the original amount that you started with. All right, next slide. Find out more. When a quantity changes over time, it is often useful to compare the original quantity and the new quantity by describing the difference or the amount change as a percent. The percent change is a ratio that compares the amount of the change to the original amount. Okay, so this is basically the main idea that we're going to be using today. The percent change will be a percent increase when the new amount is greater than the original amount. The percent change will be a percent decrease when the new amount is less than the original amount. You're going to use a ratio to find Suzanne's June earnings. So she usually makes $40, but she made more this year. So, which equals 200%, or 200 over 100. So this is where we can cross multiply. So you can do 200 times 40, which comes out to, I believe, 8,000. And then you cross multiply x times 100, which is 100 times x, and you divide it. And then you get 80 equals x. So she increased her earnings by $80. So she increased her earnings. So you're going to take the original $40 she earned plus $80 to equal 120. Percent error is the ratio describing how far an estimate is from the actual amount. For example, if you estimate that the book is 11 inches long, but it really is 10.875 inches long, the percent error is 0.125 over the actual amount, or about 1.1%. And we'll get more into these examples later on in the lesson. All right, the reflect page. How is a percent error like a percent change? Well, the percent error, the numerator is the difference between the two quantities, and the denominator is the original or actual amount. So basically, the numerator, or some say, the top, numerator is the amount change, and the denominator, or the bottom, denominator is the original or actual amount. Okay, Read the problem below, then explore different ways to find the percent change. Well, Nassim scored 5 goals in his first soccer season and 8 goals in his second soccer season. What was the percent increase in the number of goals he served? Well, first off, you got to figure out the amount changed. So the amount change is going to be 8 minus 5, which is 3. So the amount change between the first game and the second game is 3 goals. Well, the original amount he started off with was 5 goals. So we got to figure out the percent of this. So it would be x over 100. So again, we're going to cross multiply. So x times 5 is just 5x. 3 times 100 is just 300. So then you're going to divide by 5. And x goes into 360 times. Well, excuse me, 5 goes into 360 times. My bad. So that means my percentage is 60%. Okay, so we're actually going to skip those questions. And let's go try another problem. So Amelia's mom baked 48 cookies. After Amelia and her friends walked through the kitchen, there are 18 cookies left. What percent in decrease? What is the percent decrease in the number of cookies? Well, again, first thing you need to do is figure out the change between the two numbers. So you're going to take the first, the amount of cookies she baked minus the amount of cookies are left. So a total of 30 cookies were changed or decreased. So 30 cookies were taken away. So you got 30 over 48 because 48 is the original amount you started with, and x over 100 because you want to figure out the percentage. So again, we're going to do the same thing. X times 48 is 48x. 30 times 100 is 30,000. And then you're going to divide 48 into 3,000. And when you divide 48 into 3,000, you'll get 62.5%, which is B. All right, the first month Tan had his new phone, he downloaded 5 apps. 6 months later, he had 22 apps on his phone. What's the percent increase in the number of apps he started with? So again, you got to find the difference between the amount he started with and the amount he ended with. And 22 minus 5 is 17. So you have 17 over 5. The reason why it goes over 5, because that's the original amount he started with. I know this looks a little weird, but he increased his apps by a lot. And so then it'd be x over 100. So then you do x times 5, which is 5x, and then 17 times 100, which is just 1,700. And then you divide by 5 to both sides. Well, 5 goes into 1,700 340 times. Yes, that is correct. It is 340%. He increased his apps by 340%. That's true because he started off with 5 and he's ending with 22. So he increased it 340% times. Okay. Leo estimates that a package weighs 24 pounds. The postal clerk weighs and finds that it weighs 20 pounds. So we got to find the percent error. So again, it's the same idea that we've been doing. So you have to start off with the original amount and subtract it, and you get 4. Well, that means it's going to be 4 over 20. The reason why it's not 4 over 24, the amount that he thought it was, is because 20 is the actual amount. So you have to do it over the actual amount because you're trying to figure out what his error was. So to figure out his error, you have to put it over the actual amount. So again, it will be 4 over 20 is x over 100. Well, we're going to solve this a little bit different way. Instead of cross multiplying we've been doing, we're going to figure out how does a 20 get to 100? Well, I can multiply 20 by 5. Well, what you do to the bottom, you do to the top. So I'm going to do 4 times 5, which is 20. So my answer is 20%. So then let's go on and try some more problems. We're going to skip the questions again. Emma needs 84 centimeters of ribbon. She measures and cuts pieces from a spool of ribbon. Later, she found out that she actually cut 80 centimeters of ribbon. What was her percent error? So again, we're going to start off. You're going to figure out the difference, which is 4. So then you're going to do 4 over 84 because she needs 84 centimeters of ribbon, but she only cut 80. So we got to figure out her error. So it'll be x over 100. So now I don't know what I can multiply by 84 to get to 100 nicely. So we're just going to cross multiply. So 84 times x and 4 times 100 is 400. So then you're going to divide 84 to both sides. This cancels out, and get my x. 84 goes into 400 about 5 times. So we round it up to 5%. So she made about a 5% error because it wants the nearest whole percent. Okay. Christopher estimates it'll take him half an hour to complete his math homework. He is able to complete it in 25 minutes. What's the percent in error? Well, originally he thought he can do it in 30 minutes, but his actual time is 25. Well, the difference between 30 minutes and 25 minutes is 5 minutes. We can put that over 100, x over 100. Well, 25 times 4 is 100. So what you do bottom, you do to the top. And 5 times 4 is 20. So it means he can do it. He had a 20% error. Okay. So the homework is pretty straightforward, but if you do get stuck on it, let me know. Other than that, it's just 6 problems. Please watch the video. I personally love this lesson. I like finding percent increases and percent decreases and percent errors. If you do have problems with the formula, though, let me know. Other than that, have a great day. Bye.